Good morning, grade 11 STEM students. How are you today? I hope that you are all doing fine. Today, we'll discuss another lesson in General Chemistry 1, and that is about limiting an excess reagent. After going through this module, you are expected to 1. Explain the concept of limiting an excess reagent in a chemical reaction. 2. Identify the limiting reagents and the excess reagent. And 3. Appreciate the essence of limiting reagent in production of compounds. Before we proceed, let us measure your knowledge about this lesson. Take the pretest. You have to choose the letter of the best answer. Number 1. In a reaction between two reactants to form products, the reactant that is fully consumed is called blank. A. Excess reagent. B. Percentage yield. C. Stoichiometric factor. Or D. Limiting reagent. The answer is letter D. Limiting reagent. Number 2. In order to determine the limiting reactant in a chemical reaction involving two reactants, one must block. A. Calculate the bond energies. B. Calculate the mass of a single product formed from each reactant. C. Determine the molar masses of the products. Or D. Determine the respective masses of 1000 mole of each reactant. The answer is letter B. Number 3. Which of the following is an indicator that the chemical reaction has stopped? A. Loss of mass. B. Formation of precipitate. C. Unchanged number of moles. Or D. Loss of energy. The answer is letter B. Number 4. Study the experimental setup shown here. Two different colors represent two kinds of reagents. If the reaction is successfully completed, which of this is the limiting reagent? And the answer is letter A. Question number 5. In the industry, the cheaper reactant is usually used as blank. A. Catalyst. B. Excess reagent. C. Enzyme. Or D. Limiting reagent. Letter B is the answer. So what's your score? Did you get them all correct? If not, do not worry, because we shall have a discussion of these concepts. But before the lesson proper, let us have a recap of what you have learned in your previous self-learning modules. You must identify the terms that is being described by these statements. Number 1. It is a type of chemical reaction that involves breaking down of the reactant to form two or more products. Number 2. He is responsible for the experimentally defined value that is used in stoichiometric calculation. 3. It is a type of chemical reaction which usually involves a hydrocarbon reacting with oxygen to produce carbon dioxide and water. 4. It is a type of chemical reaction that involves the formation of a product from two or more reactants. Number 5. This type of formula can be obtained by calculating the percent composition of a particular compound. 6. It is the SI unit for amount of substance used to measure large quantities of very small entities such as atoms, molecules, or ions. 7. In writing a chemical reaction, this is placed on the left side of the arrow, which is also known as starting substances. And 8. This is usually produced after a successful chemical reaction. And here are the correct answers. Did you get them all correct? Congratulations! I think you are now ready with our lesson, which is about limiting and excess reagents. What is it all about? You might find it a little bit abstract at this point. In understanding this lesson, maybe this comparison could help. Do you eat pandesal? It's a famous bread that is eaten by most Filipinos in the morning. You can easily buy pandesal in nearby places, but the most famous pandesal can be bought in the Masalang Bakery located at Kapasigan, Pasig City. Did you know that this bakery is more than 100 years old? Would you like to make pandesal? The diagram here is just hypothetical. If we could prepare one pandesal from 2 eggs and 1 cup of flour, how many pandesal do you think can we make from 10 eggs and 7 cups of flour? In this hypothetical situation, 1 cup of flour is needed for every 2 eggs to produce 1 pandesal. Since we have 10 eggs, then we only need 5 cups to produce 5 pandesal. There is an excess of 2 cups of flour, therefore flour is the excess reagent and egg is the limiting reagent. So what then is a limiting reagent and what is an excess reagent? Limiting reagent refers to a reactant that is first used up or consumed in the reaction, since the maximum amount of the target product depends on how much amount of this reactant was originally present. By the time that this reactant is used up, no more products can be possibly formed. While excess reagent refers to a reactant present in amounts greater than what is required to react with the quantity of the limiting reagent. Let us now apply these concepts in solving chemistry-related problem. Sample problem number 1. Isopentyl acetate is the banana-flavored ester used particularly in giving a banana smell and taste of a particular food. The synthesis of isopentyl acetate is shown in this reaction. Let us try to determine how much isopentyl acetate could be made if we only have 1 mole of isopentyl alcohol and 10 moles of acetic acid. For our solution, the first thing that you must do is to check if the equation is balanced. So based on the balanced equation, for every 1 mole of acetic acid, only 1 mole of isopentyl alcohol is required to produce 1 mole of isopentyl acetate and 1 mole of water. Therefore, there is an excess of 9 moles of acetic acid. Therefore, acetic acid is the excess reagent, while isopentyl alcohol is the limiting reagent. Sample problem number 2. Consider the reaction between hydrogen gas and nitrogen gas to produce ammonia. If 6.60 moles of hydrogen gas are made to react with 4.42 moles of nitrogen gas, what is the limiting reagent? How many moles of ammonia will be produced? And what reagent is in excess and by how much? For our solution, the first thing that you must do is to check if you are working on a balanced equation. Then we have to determine the mole ratios of reactants and products from the balanced equation. So based on this equation, 3 moles of hydrogen gas is to 1 mole of nitrogen gas is to 2 moles of ammonia. We can now calculate the number of moles of the product, which is ammonia, based on the initial amount of reactants, which are hydrogen and nitrogen gas, using the mole ratios found on the balance equation. The limiting reagent will yield the smaller amount of the product, thus, the other reactant will be considered as the excess reagent. If you will look closely at the computation, you can see that the number of moles of hydrogen will yield the smaller amount of the product rather than the moles of nitrogen gas. Therefore, hydrogen will be considered as the limiting reagent while nitrogen gas is the excess reagent. So how many moles of ammonia will be produced? The answer depends on the limiting reactant. Since hydrogen is the limiting reactant, then the number of moles of ammonia produced is 4.40 moles. For the question what reagent is in excess and by how much, we already know what is the excess reagent, that is nitrogen gas. The only question left is by how much of nitrogen gas is left after the reaction. For our solution, since 4.40 moles of ammonia is produced, we need to determine the moles of nitrogen gas required to produce this much of ammonia using the mole ratios. From the equation, we can see that 4.40 moles of ammonia would only require 2.20 moles of nitrogen gas. From the given 4.42 moles of nitrogen